Hello students, welcome back. Previously we have learned about matrices, that what are matrices, what are the types of matrices, what are the operations involved in matrices. Then we have learned how to find out its determinant and how to find out inverse of a square matrix. Okay, so in this part of my lecture we will be learning how to solve a system of linear equation by using matrices. Okay, so this part particularly involve how to solve system of linear equations. Okay, so first of all, the topics that are included in this part is we need to know what are the types of systems. So I will be giving you a very small introduction on the types of systems. Then we will be learning how to find out the solution of the linear equations. Now for that we have three basic categories, or this linear equations can be solved in three ways. So we will be discussing three ways out here. Okay, the first is matrix inversion method, Cramer's rule, and the last is Gaussian elimination. Okay, so first of all we are moving towards the introduction to types of systems. Now there are two types of equations. Okay, one is called the homogeneous and non-homogeneous equation. Now let's just find out what homogeneous and non-homogeneous equations are. A linear system of equation ax equals to b is called homogeneous if b equals to 0, and non-homogeneous if b is not equals to 0. Notice that x equals to 0 is always solution of the homogeneous equation. Now what does that exactly mean? See, whenever a system of linear equation is written in the form of matrix, it has its form ax equals to b. Okay, or a general linear system of equation is written in this form, ax equals to b. So this is basically the general system of equations written. Okay, where a is any coefficient, x is representing the variable, whereas b is representing the constants involved. So okay, so whenever any sort of equation is written, it's written in this form. This is basically the general system of equation. Okay, so whatever equation you write it down, it's written generally, it's written in this form. Okay, now it says that if it is homogeneous, only if b is equals to 0. Okay, and non-homogeneous if b is not equals to 0. If this is my constant number, b is my constant number, so see, if b is equals to 0, okay, so the system will be a homogeneous system, and the solution for the homogeneous system will be 0. Right, so let's just imagine something. We have, let's say we have taken an example. We'll take an example, let's say 2x equals to 0. Right, so if I want you to calculate what is the value of x, so the value of x will be 0. Okay, so this is basically my homogeneous system. Whereas for non-homogeneous system, b is not equals to 0, and there exists a solution for non-homogeneous equations. It can be 0 or it can be any other solution. Okay, so just like it's like 2x equals to 1. Now instead of b, I have said 1. So 2x equals to 1. If I ask you what will be the value for x, you can say that x equals to 1 by 2. Okay, so general system as it is says that it's ax equals to b. Okay, so this is how the general system and system of equations work. Okay, we are moving on towards the solution of linear equations. Now first of all, we will be doing matrix inversion method. Okay, now what is matrix inversion method? Let's just take a set of equations. Okay, these are two set of equations. The first equation is 3x plus 4y equals to 5. The second set of equation is 2x minus y equals to 7. Okay, so this is basically, there are two equations written out here and both are linear. Why they are linear? Because the degree of this equation is 1. Okay, degree means the highest power of the variable appearing in the equation. Out here it's a two-dimension equation and both has degree 1. Alright, okay, now in order to solve the above system, consider Ax equals to b. Now as I said earlier that all systems are written in the form Ax equals to b. Okay, this is written as Ax equals to b. Okay, now if I need to write it down in the form of a matrix, now how will I be able to solve it? How will I be able to write it down? Now A, as I said, are the coefficients. Okay, as I said earlier that A are all the coefficients. B, x means the variable, okay, whereas b are the constants, right? So when we are representing this set of equation, these two equations in the form of a matrix, how we will represent it? Now this is A means a coefficient matrix, okay, x will be a variable matrix, whereas b will be a variable matrix, constant matrix. Okay, now for coefficient matrix, what we are going to do is that we are going to say that these 3, 4, 2 and -1 are the coefficients. So we're going to make a matrix. Since there are only two equations, that means that it will form a matrix of order 2. 2 rows and 2 columns are involved in this type of equation when there are only two variables. Okay, now I have written it in a form of matrix 3, 4, 2 and -1. Okay, this is how we write down a matrix. So when we are writing a system of linear equation in terms of a matrix, this is how we write it: 3, 4, 2 and -1. Now when it comes to variable matrix, now there are two variables involved. First is x and then y, x and y. So there are only two variables. We're going to write it down in a form of a column matrix. Okay, a column matrix, let me tell you, is those type of matrix that have only one columns but they have multiple rows. Okay, they have n rows involved, right? So this is basically my column matrix. And then comes my b, that is the constants. Now out here equals to 5 and equals to 7, these two are my 5 and 7 are my constant. So b equals to 5 and 7, I will be writing it in the form of a column matrix. Now let me tell you again, column matrix means one row and they can be one column and they can be n rows. There can be multiple rows but there is only one column in column matrix. Okay, so now, okay, when we say that we are dealing with a general system, this Ax equals to b, right? When we are solving system of linear equation, we are talking about finding a value of x and y, right? That means if I take this general system Ax equals to b, we wanted to solve for x, right? We want values for x. Okay, this capital X are representing all the variables that are involved in the linear equation system. Now if I wanted to find out value for x, out here as you can see earlier that it was written Ax equals to b. So what I did is I just write it down, one thing, the one thing that I need to find out on one side, and I shift everything on the other side. Okay, is equals to A inverse B. Now usually what happen is that B, it's like B divided by A, and you know that matrices don't support divisions. Okay, so what we are going to do is, since matrices don't support divisions, what we are going to write is x equals to that division of A will be written somehow like this: A inverse B. So it's just basic thing that if you just write it down, B divides A. Okay, so A, it's in the denominator and you need to put it or place it in the form of a numerator, right? You don't want that division type of thing to be shown. So what you're going to do, that since in denominator its power is +1, you move it upwards, the power will be -1. So this -1 in matrices actually represents inverse. Okay, because, and the second thing is, since matrices doesn't involve division, okay, it doesn't support division, so you know how we will be finding out values for x when we need to shift everything on the other side. It's like x equals to A inverse B. Okay, then we know that formula for A inverse is equals to adjoint of A divided by determinant of A. Now out here it is very important that you all need to know that determinant of A should not be equal to 0. If it is 0, we won't proceed further, whether it is a 2 by 2 system or a 3 by 3 system. Okay. Now what I have done here is that see, this was my matrix. Okay, and I need to find out value for x, right? So I need to find out its determinant. I have calculated its determinant, and its determinant is -11. Alright, now I will be finding out its adjoint. Now I have told you all that how to find out adjoint, so by using that I have find out my adjoint as well, right? Now the final thing is that I will be finding out A inverse. Why I am finding A inverse out here? The thing is, see, we have variables x vector, right, or x column matrix, we have B column matrix, we don't know the A inverse. So for that we need to find out this A inverse out here. Okay, so this is my A inverse. Now what I did here is that I have substituted everything into this equation, that is x, which capital X represents my variable matrix, column matrix, x and y equals to A inverse. The answer for A inverse is this, right? Multiply by B. B is what? B is my column matrix, or you can say my constant, the column matrix that has constants in it. Okay, now out here when we are multiplying two matrices, we need to know that two matrices will only be multiplied if and only if the column of first matrix is equal to the rows of second matrix. And now out here you can see it is possible, right? So it is possible, the multiplication between these two matrices, like this matrix and this matrix, is possible. Now it is up to you. Okay, you multiply these two matrices first and then divided it by -11, or you just divide this matrix by -11 then multiply it with this matrix. It's completely up to you. Okay, what I have done here, I've just multiplied it first. I've multiplied two matrices. Okay, so this is some of the simplifications, right? These are the simplifications, and when I just multiplied it and I finally simplified it, I divide each and every element of this matrix with this number. Okay, it's just like scalar multiplication. When in scalar multiplication you just multiply with the number inside, right? So since the number out here is 1 by -11, you just multiply -33 multiply by 1 upon -11. So this is what you get in return. Okay, here you go. So the answer for, when you just simplify this, you get 3 and -1. Now what will be the answer? Since two matrices are equating each other, okay, so how to find out value for x and y? You can see x equals to 3 and y is equals to 1. Okay, so this is the final answer. X equals to 3 and y is equals to 1. They both are equating each other, and this first row and first column, okay, first row first column of this side will be equated to the first row first column of this side. First second row first column of variable matrix is equal to the constant of multiplication that we got afterwards, that is -1. So this is how you get your answer. X equals to 3 and y equals to -1. Now what you can do is you just substitute these answers into your question, okay, and you'll get right hand side equals to left hand side, which verifies that the answers that you have calculated are correct. So I just leave that thing up to you all. So you just check it. It's for verification, so that you need to know that how verification is done. All right. Okay, now here I have taken a 3 by 3 system. Now 3 by 3, how can I say it's a 3 by 3 system? See, it has 3 dimensions. 3 variables are involved out here. 1, x, y and z, right? So there are 3 variables. X, okay, in this equation there is no y, no problem. X, y and z. So when I wanted to write in a general system, we know that the general system is ax equals to b. So if I need to find out a, that is the coefficient, okay, a is basically the coefficient matrix. If we wanted to write down the coefficient matrix by looking at these system of equations, see, my first row will be 1, 1 and 1. Second row there is no x, so 0, 2, 5. Third row 2, 5 and minus 1. So this is how I have written my coefficient matrix. Now x represents all the variables, so there are 3 variables, x, y and z. There you go, x, y and z. For b it is equals to 6 minus 4, 27. So 6 minus 4 and 27. Now as you know that I've explained you earlier that we wanted to find out variables, the values of all the variables. So what I'm going to do, since the general system was written in the form this ax equals to b, if we need to find out values for x, so we'll shift this to the other side and it will then become x equals to a inverse b. Now a inverse, you need know the formula for a inverse, that is equals to adjoint of a divided by determinant of a. Now out here what I have done here, that I have just finally simplified and calculated. You can see how we have calculated inverse. Okay, so yeah, so this is my final answer for inverse, right? When this is my final answer, what I have done in afterward, that I've just placed all the answer that I got here into this system of equation, into this equation, right? X equals to the a inverse thing and b, that is 6 minus 4 and 27. Now again it is up to you whether you wanted to multiply these two matrices first and then divide it by minus 21, or you just divide it by 21 and then multiply with each other. Okay, after just simplifying it, I get the final result. Now x equals to 5, y equals to 3. It's like position to position, we will equate it from whatever position it's written out here will be equated to the position here. Okay, y equals to 3, z is equals to minus 2. These are your final answer. Now again you can verify your answer by putting these values into your equation, and there you will see that left hand side and right hand sides are equal, so which verifies actually that this is your correct answer. Moving on. Okay, the second the second way of using matrices and solving linear of equation is Cramer's rule. Okay, so basically Cramer's rule involve all the determinants, so you need to be know how determinants, how you calculate determinants, or you should know how to calculate determinants. Sorry, solve the following system by using Cramer's rule. All right, okay, now this is my system. Okay, I have used a 3 by 3 system here. Now how can I say it's 3 by 3 system? Because there are 3 unknown variables and there are 3 equations given. Okay, 1, 2, 3, so it's a 3 by 3 system. There will be 3 rows and 3 columns. Now coefficient matrix. Now coefficient matrix, you all know how to write a coefficient matrix. You just use, as we were doing earlier, when a system of equations are given, ax equals to b, a general system, the coefficient is always the numbers that are written with the variables. 2, minus 1, out here 2, minus 1, 6, minus 3, 4, minus 5, 8, minus 7 and minus 9. Okay, here you go. Okay, alright, we have written a coefficient matrix out here. Okay, The next thing that is, we will be finding out its determinant. Since I said earlier that Cramer's rule basically depends on the determinant thing, right? So you need to know how to calculate the determinant. If you wanted to know how to calculate determinant in detail, you can go through my previous part where I have actually told you how to calculate a 3 by 3 determinant. Okay, so out here I just directly calculated determinant. Okay, and I got this determinant, that is minus 141. Now this is up to you, you calculate it on your own so that you can verify your answers out here. Okay, now formulas. See, we will be here. Okay, yeah. Now as you all know that we wanted to find out value for x, y and z. Now if you wanted to find out value for x, the formula will be modulus, that is determinant for ax, divided by determinant of a. Now you are familiar with what is the determinant of a, right? But you don't know what is the determinant for a of x, right? So it's written like a subscript, x is written in the subscript, so we need to know what is that. For y, it's like determinant of ay divided by determinant of a, and for z, it's az, determinant of az divided by a, divided by determinant of a. We all know what is the determinant of a means. Now what does determinant of ax, ay and az means? We need to know that first. Okay, see, when we wanted to find out determinant of ax, right, we're going to change a matrix. What we are going to do, that we are going to substitute first column of a matrix, of a coefficient matrix, with the constant matrix, right? That means that we're going to substitute first column of the matrix, of our original matrix, with the elements of our B matrix, of our constants. So it's like C1, C2 and C3. See, earlier minus 1, 4, minus 7, 6, minus 5, minus 9, it's same as written in the coefficient matrix, but this thing is changed. Now what are these 10? Where did they come from? Let's just go back a little. Okay, now here you can see these are my constant values, right? This is, let's say this is C1, C2 and C3, and it is 10, 11, 12. Earlier in matrix inversion method we used to say them as B, describe them as B, which means the constant matrix, right? So it's just like that, constant matrix. Okay, what we are going to do is, okay, so in the coefficient matrix we have substituted first column by the constants, by all the constants, since we have 3 equations involved and there are 3 constants. Okay, now what I have done here is, as you can see, I have calculated its determinant, and it's minus 1499. Now you can again calculate it on your own and check and verify your answer, that how this determinant is calculated and the answer is correct or not. Okay, then for ay, now for ay what we are going to do is a11, a21, a31, a13, a23, a33. These 2 columns are same as of coefficient matrix, but the second column is actually substituted with the constants C1, C2 and C3, like this. See, earlier 10, 11, 12 were written in first column. Now they are written in second column. 2, minus 3, 8, 6, minus 5 and 9. These are the same values as in of coefficient matrix. Now when we reach this stage, we're going to again find out its determinant, and I've already calculated it. It's minus 1492, right? So you just calculate it and verify your answer. Now for AZ, now since for AZ the third column remains, the third column is substituted by the constants, and the first 2 column remains as it is, like this. Earlier in the first part we saw 10, 11, 12 were written in this column, then it were written in this column, and finally for Z right? For z it will be written in the third column. Az equals to 16. I've already calculated its determinant and it's equals to 16. Now x, you know the formula, x equals to determinant of x ax divided by determinant of a. Since we have already calculated determinant of a, which was equals to minus 141, and determinant of ax is minus 1499, we just substitute value for y and for z as well. Okay, and these are my final answers. The same applies that you can, if you wanted to verify your answers, substitute these values into your equation and you can check both right and left hand side's answers are equal. So there you will know that your answer that you have calculated are correct.